All right, the next skill that we need to work on is how to represent these organic molecules. You'll need to both be able to draw these and to see them and be able to interpret them. So it's going to work both ways. But I find the easiest way is if I teach you how to draw them, you'll also be able to read them. So in your notes, we've got the 5 listed here. We're going to cover all 5, although really these bottom 3 are the ones that we're going to use the most by far. Expanded molecular, you'll probably see a little bit. Molecular, you'll understand here in a little bit, is almost entirely useless to us in organic chemistry. But let's go through them all anyway. Molecular formula is just a list of what's there. It doesn't give it in any order or structure or anything, just lists exactly what we have. So for example, C5H12. I know I have 5 carbons and I have 12 H's, but I have no idea what their arrangement might be. Expanded molecular gives us a little bit more information, as that groups of atoms tend to be put together in clumps rather than just listed as like 5 carbons. And one thing to notice here is also that if you have anything in brackets, that's usually talking about a branch. So this molecule might look something like this. CH3, there's my first clump, and then I have a C with 2 H's, then I have a C with 1 H, and then a bracket CH3. So that tells me this clump, this CH has, or this carbon has 1 H and a branch coming off of it, which is a CH3 branch, and then another CH3 at the end. So it's the same information. It's still 5 carbons, it's still 12 H's, but now they've at least given me some idea of how those molecules, or those atoms I should say, are arranged in this molecule. Structural diagram is the one that we're going to use, is one of the first ones we're going to use a lot, and that's where the entire shape of the molecule is drawn with every bond and every atom that's connected to it. So let me get me out of the frame here so I can show this to you. And so this would look like this. My first CH3 group would be a carbon, and it would have 3 H's attached to it. Then I would have another carbon with 2 H's attached to it, another carbon that has 1 H, and a CH3 branch coming off of it, and then another, too close, another C with 3 H's. So that's what that molecule would look like in a structural diagram. So hopefully that makes sense. It's basically just our Lewis and structural diagrams that we talked about before. We just jump right to that. And you could follow your honk rule if you wanted to double check that your structural diagram is correct. Condensed structural is kind of a combination between the expanded molecular and the structural diagram, where we take and we clump the molecules, or sorry, we clump the atoms together in groups to simplify our diagram, but we still draw the overall shape that it's forming. So I'll draw this at the bottom here. I may have to draw the line diagram somewhere else just because it's hard to draw really small on my page here. But yeah, let's just do that. So this first one would be a CH3. It's attached to a CH2. It's attached to a CH that has a CH3 branch, and it's attached to a CH3. So again, same information. It's just a little bit more condensed than having to draw out every individual hydrogen and every individual bond. Just simplifies things down and makes things a little bit quicker for us. Okay, the line diagram is by far the fastest, but it can be the hardest to read and to figure out sometimes. So when you're figuring out line diagrams, I would write next to this somewhere, wherever you've got a little bit of room, that the carbon atoms are every end or bend. So anytime that the line has an end or it has a bend that doesn't tell me something else is there, I'm going to assume that that is a carbon. So the line diagram for this molecule would simply look like this. And that's it. So we would assume that every time there was an end or a bend, so that would mean here's an end, and here's an end, and a bend here and here, that each of those points are carbons. We don't show them, we don't list them, but we're going to they're implied that those are carbons. The other part that's tricky for people to sometimes see is that the hydrogen atoms aren't shown at all. They're also just implied. But if we remember the honk rule, I know that every carbon wants to form 4 bonds. So if we start on the left side of this, that carbon on the very end wants to form 4 bonds, and right now it's only forming one that I can see, which means that there are 3 implied hydrogens there, although we wouldn't draw them in. This next carbon has 2 bonds that I can see between carbons, so there are 2 implied hydrogen bonds there. The next one's already forming 3 bonds, so there's 1 implied hydrogen there, 3 here, and 3 there. So you need to be able to figure those out, even though in the actual drawing we would never draw in those marks. The line diagram would just look like that, and you'll need to be able to read and interpret any of those to understand whether you're looking at, like to be able to read how many carbons, how many hydrogens, to be able to name it appropriately. You should be able to do structural, condensed, and line. Those are the 3 big ones that you really, really need to focus on. All right, let's stop there, and I'll do one more video to introduce you to isomers.